students, welcome to Sunil's tutorial. I'm Sunil Mirwani and today we'll be doing this chapter called as EMI. Take down the sum please. Find the reactance of a coil. Find the reactance of a coil. Find the reactance of a coil of inductance 100 millihenry of inductance 100 millihenry at a frequency of 50 hertz and at 1000 hertz. Now first part, at 50 hertz. Inductive reactance is nothing but 2 pi FL, right? Where F I'll take as F1. This is going to be 2 into pi into F into L. Multiply, you should get your answer. You should get the answer as 31.42 ohms. Similarly, at 1000 hertz, XL again will be nothing but 2 pi FL. The only thing is here you will take F2. Same way, just straightforward multiplication. You should get the answer for this as 628.4 hertz. Next, take the next one please. At what frequency? At what frequency will 0.5 Henry, at what frequency will 0.5 Henry have a reactance of 2500 ohms? At what frequency will 0.5 Henry have a reactance of 2500 ohms? Again, I can use the same formula. Inductive reactance is equal to nothing but 2 pi FL. You know XL, you know L. You should be able to get the frequency when you solve this. You should get the answer for this as 795.7 hertz. Next, take on next one please. When a voltage of 200 volts, when a voltage of 200 volts is applied to an inductor, a current of 20 milliamps, a current of 20 milliamps flows through it. A current of 20 milliamps flows through it. Find the inductive reactance. Find the inductive reactance. Ohm's law. XL is equal to E RMS upon I RMS. They've given you the RMS voltage, they've given you the RMS current. Divide the two, you should get the answer. The answer for this should be 10 kilo ohms. Next, take on next one please. Find the current through an inductor coil. Find the current through an inductor coil of inductance 2 Henry. Find the current through an inductance coil of 2 Henry connected to an AC source. Connected to an AC source of 230 volts and 50 cycles per second. And 50 cycles per second. IRMS. They've asked me to find out the current. It is voltage upon resistance, so voltage upon reactance. But XL we know is nothing but 2 pi FL, so this will be ERMS upon 2 pi FL. LF I know, ERMS I know, so I should be able to get IRMS. All the data is given to me. Substitute and you should get the answer for this as 0.366 amps. Next, take down next one please. Find the capacitive reactance. Find the capacitive reactance of 10 microfarad capacitor connected to a frequency of 50 Hertz. Connected to a frequency of 50 Hertz. Connected to a frequency of 50 Hertz. Xc is equal to 1 upon 2 pi Fc. F is given to you, C is given to you. You can substitute and get the answer. The answer for this sum should be 318.7 ohms. Right. Next, take on next one please. A 50 cycle AC supply. A 50 cycle AC supply has an inductor of 1 upon pi Henry. Has an inductor of 1 upon pi Henry and a resistance of 2 kilo ohms. Calculate the impedance in the circuit. Calculate the impedance in the circuit. Now first of all I can say inductor reactance is equal to 2 pi FL. They have asked me to find out impedance in the circuit. Impedance is nothing but square root of R square plus XL square. Resistance is given to me, XL I can find out. Put it in this formula, you should get the answer. The answer for this sum should be 2002 ohms. Next, take down next sum please. When 100 volts DC, is applied to a coil, a current of 1 amp, when 100 volts DC is applied to a coil, a current of 1 amp flows through it. When 100 volts AC of 50 Hertz, when 100 volts AC of 50 Hertz is applied to the coil, a current of 0.5 amps flows through it. Calculate the resistance and inductance of the coil. Calculate the resistance and the inductance of the coil. Calculate the resistance and the inductance of the coil. Now resistance, straightforward, DC voltage upon DC current will give you the resistance of the coil. That's the first thing that you will do, right? This is going to be nothing but 100 upon 1, that's 100 ohms. So the resistance of the coil is 100 ohms. Next, I can find out the impedance of the circuit. Impedance is nothing but ERMS upon IRMS. ERMS is 100 upon 0.5, right? So this is going to be nothing but 200 ohms. So I come to know the impedance of the circuit. Once I know the impedance of the circuit, I can say but impedance is nothing but square root of R square plus XL square. Square both the sides, so I'll get Z square is equal to R square plus XL square. So 200 square minus 100 square is equal to XL square. Substituting the value, A plus B, A minus B. So A plus B, 300 into A minus B, 100 is equal to XL square, right? But XL is nothing but 2 pi Fl, right? Now first of all I can say that this is 100 into 100 into 3 is XL square. So 10 into 10 into root 3 is XL. So 100 into root 3 is XL. Root 3 is 1.732. So 173.2 ohms is equal to XL. Once I know XL, I can say but XL is equal to 2 pi FL. 173.2 is equal to 2 pi F L. L is the only unknown in this equation. When you solve this, you should get the answer of inductance as 0.5512 Henry. Next, take down next one please. An AC of 230 volts. An AC of 230 volts and 50 hertz is applied to 10 Henry and 300 ohms. Find the inductive reactance, power factor and the current. Also find the power absorbed. Find the I'll just repeat the question. They're saying that an alternative an AC voltage of 230 volts, 50 hertz is applied to 10 Henry and 300 ohms. Find the inductive reactance, power factor and current. Also find the power absorbed. First, you will have to find out the inductive reactance XL. XL is nothing but 2 pi FL. F you know, L you know, you should be able to get XL. Next, you can find out impedance in the circuit. Impedance is nothing but square root of R square plus XL square. That will give you the impedance in the circuit. Next, they have asked you to find out the power factor. Power factor is cos phi. Cos phi is nothing but R by Z. That's called as my power factor. I know resistance given, impedance I have found out, so I should be able to get the power factor. Next, They've asked me to find out the current in the circuit, I. IRMS is nothing but ERMS upon Z. And last, they've asked you to find out the power absorbed in the circuit. The power absorbed in the circuit is nothing but ERMS into IRMS. Right? I know IRMS, I know ERMS, I should be able to get the power absorbed in the circuit. Fine, do we get this thing here? ERMS, IRMS into cos phi AC. Right? So cos phi is also known to be, ERMS is known to be, IRMS I found out, cos phi I found out, so I should be able to get the answer. The answer for this sum should be inductive reactance should come to 3142 ohms. Next, impedance is 3156 ohms. Power factor cos phi is 0.0951. Current IRMS is going to work out to 0.0728 amps. And last, power absorbed in the circuit is nothing but 1.539 watts. 593 volts. Right, that should be the answer for the question. Next, take down next one please. A capacitor of 20 microfarad. A capacitor of 20 microfarad. Sorry, is connected in series. With 25 ohms resistance, is connected in series with 25 ohms resistance, has a peak EMF of 240 volts and 50 Hertz AC. Find the capacitive reactance, impedance and maximum current. Find the capacitive reactance, impedance and maximum current. Capacitive reactance is 1 upon 2 pi Fc. So I should be able to get the capacitive reactance. Frequency is given to me, capacitance is given to me. Second, they've asked you to find out the impedance. Impedance is square root of R square plus XC square. Right? Resistance is given to me. XC I've just found out, so I should be able to get the impedance also. And last thing they've asked me to find out is maximum current, that means peak current, IO, is peak EMF upon impedance. That will give me the peak current. All the three things you should be able to get. The answer for this should be capacitive reactance is 159.2 ohms. Then impedance is 161.1 ohms. And peak current is 1.49 amps. Next, take our next one please. A circuit has resistance and reactance. A circuit has resistance and reactance each equal to 100 ohms. Each equal to 100 ohms. Find the power factor. Find the power factor if the current is 1.5 amps and voltage is 200 volts. Also find the average power consumed in the circuit. Also find the average power consumed in the circuit. Also find the average power consumed in the circuit. First thing that you need to do is find out impedance. Impedance is nothing but square root of R square plus X square, resistance plus reactance. Next, they've asked you to find out power factor, cos phi. Cos phi is nothing but R upon Z. Impedance you already found out, resistance is given to you, you should be able to get the power factor. Third, they've asked you to find out the average power consumed. Average power consumed is ERMS into IRMS into cos phi. Cos phi you've already found out. You should be able to get the answer for this. The answer for this sum should be impedance should be 141.4 ohms. Power factor should be 0.707 and power is 212.1 watts. Next, an AC voltage is given by E is equal to 310 sine 314t. And AC voltage is given by E is equal to 310 sine 314t. It is applied to a series combination. It is applied to a series combination of 25 microfarad capacitor, 25 microfarad capacitor, 0.1 Henry inductor, and 24 ohms resistor. Find the reactance and the impedance. Find the reactance and impedance. Now they've given you that E is equal to 310 sine 314t. Compare this with E is equal to E0 sine omega t, in which case I can therefore say that E0 is 310 and omega is 314, right? Now once I know omega, then I can find out, first thing I can find out is inductive reactance, which is nothing but omega L. I know omega, I know L. So this is going to be 314 into 0.1, that is 31.4 ohms. Next, I can find out capacitive reactance. Capacitive reactance is nothing but 1 upon omega C. So this is 1 upon 314 into C, 25 into 10 raised to minus 6. Right? So when I solve this, this is going to be nothing but 127.4 ohms. Right, so I know the inductive reactance, I know the capacitive reactance. So the net reactance in the circuit is the difference between the two. It is always larger number minus the smaller number. Here the larger number is XC. So it will be capacitor reactance minus inductive reactance, that will be the reactance in the circuit. So this will be nothing but 127.4 minus 31.4. So that will come out to 96. Right? Once I have this, then I can say that I know the reactance of the circuit. I can find out the impedance of the circuit. Impedance is nothing but square root of resistance and reactance. Resistance is given to me, reactance you just found out. So this is square root of resistance. Resistance was given to you as 24. Reactance is given to you as 96. Solve this and you will get your impedance to be 98.95 ohms. That will be your impedance. Next, take down next one please. A resistance of 100 ohms. Inductor of 10 Henry. A resistor of 100 ohms, inductor of 10 Henry, and capacitor of 5 microfarad, and a resistance of 100 ohms, inductor of 10 Henry, and capacitor of 5 microfarad are connected in series. To an AC source of 250 volts 50 hertz. To an AC source of 250 volts 50 hertz. Find the reactance, impedance and power factor. Find the reactance, impedance and power factor. First, let's find out the inductor reactance. 2 pi FL, F is given to you, L is given to you. You should be able to get this. Next, capacitive reactance 1 upon 2 pi FC. Again, frequency is known to me, capacitance is known to me. So my net reactance in the circuit is going to be modulus of XL minus XC. Irrespective of positive or negative, you will always take that as positive. Fine, do we get this thing here? Okay. So you will get reactance. Next, they've asked you to find out impedance. Impedance is square root of R square plus X square. That will give you impedance of the circuit. Once you have impedance, last thing they've asked you to find out is power factor. Power factor is nothing but R upon Z. So that will give you the power factor. All 5 things you will come to know. The answer for this sum should be reactance is going to be 2503.1 ohms. Right? Impedance is 2505 ohms. And power factor is 0.03992 ohms. Right? Next. Take on next one please. For the previous sum, next one. For the previous sum, find the current. For the previous sum, find the current, voltage drop across the resistor, inductor and capacitor. Voltage drop across the resistor, inductor and capacitor, power dissipated in the circuit, and the voltage magnification factor. Voltage magnification factor. Right, first thing they've asked you to find out is current. Current by Ohm's law is ERMS upon impedance. ERMS is given to you, impedance you found out, so you should be able to get this. Next, they've asked you to find out the voltage drop across the resistor, inductor and capacitor. Now, they are all in series. Voltage drop across the resistor, Ohm's law is IR, that is IRMS into the value of the resistance. Voltage drop across the inductor is IRMS into L. Voltage drop across the capacitor is IRMS into C. So you will come to know the voltage drop across the resistor, inductor and capacitor. Next, they will ask you to find out the power factor. Power factor is nothing but ERMS into IRMS into cos phi, where cos phi is nothing but R upon Z. So this will be ERMS IRMS into R upon Z. That will be the power factor, right? And the last thing that you have to find out is voltage magnification factor, Q. Q is nothing but omega L upon R. Omega L is nothing but XL upon R. XL we've already found out right in the beginning, and we also know the resistance, so you should be able to get the voltage magnification factor. The solution for this, the answer should be current is 0.0998 amps. Next, power factor is 0.996 watts, and voltage magnification factor is 3.14. Next, take on next one please. An AC voltage of 230 volts, 50 hertz is connected in series with a combination of 2 Henry inductor, is connected in series with a combination of 2 Henry inductor and a capacitor. Find the capacity of the capacitor. Find the capacity of the capacitor when the current in the circuit is maximum. Find the capacity of the capacitor when the current in the circuit is maximum. Find the capacity of the capacitor when the current in the circuit is maximum. Right? Now, when will the current in the circuit be maximum? The current in the circuit will be maximum at resonance. Right? And at resonance, we know that omega L is 1 upon omega C. Resonance is when the inductive reactance becomes equal to the capacitive reactance, right? Omega L, 2 pi FL is 1 upon 2 pi FC, Therefore, I can say that C is equal to 1 upon 4 pi square F square L. Everything goes down, C comes up, you should be able to get the value of C. The answer for this should be C is 5.071 microfarad. Right? Take down next one, please. An AC circuit has 5 ohms resistor and an inductor of 10 millihenry connected in series with 50 volts and 50 hertz. What capacitance should be connected in series? What capacitance should be connected in series? I'll repeat the sum. An AC circuit has a resistor of 5 ohms and an inductor of 10 millihenry connected in series with 50 volts and 50 hertz. What capacitance should be connected in series? What capacitance should be connected in series to obtain maximum current? What capacitance should be connected in series to obtain maximum current? And what will the maximum current be? And what will the maximum current be? What will the maximum current be? Maximum current is obtained in a series circuit at resonance. At resonance, condition for resonance is omega L is 1 upon omega C. So therefore I can say 2 pi Fl is 1 upon 2 pi Fc. Therefore you can say C is 1 upon 4 pi square F square L. So you will come to know the capacitance in the circuit. Once I know the capacitance in the circuit, next at resonance, we also know that impedance is equal to resistance, right? Therefore, they have asked you to find out the current in the circuit. Current is E upon Z, that is E upon R. You should be able to get the current in the circuit. The answer for this sum should be answer capacitance is 1014 microfarad and current is 10 amps, right? Okay, we'll stop this here for the day. Thank you very much.